All right. Here we go. So problem number 1, page 185 says, what percent of the normal curve is less than positive 0.45? Okay, so make sure you know where to find this. So normal dist, and if they didn't give you the mean and the standard deviation, use 0 and 1 for the mean and standard deviation. And then this one just says we want less than 0.45, so I'm going to go 0.45. So we're talking about 67.4% of the area. Obviously, you just take that 0.6736 multiplied by 100 to give you the percent. So that's how much area is there. And then make sure you draw that, the best you can. It doesn't have to be perfectly grayscaled, shaded with your pencil or anything, but. And then for problem number 2, we want to know what percent of the normal curve is between negative 1.3 and negative 0.3. Okay, so can I move off here? So if we go back here and we change our bounded region, we want negative 1.3. And then we want negative 0.3. Negative 0.3. All right, so it's just a smaller little wedge. So that accounts for 28.5% of the area. Does this make sense? Seem easy to do? It's like, dude, we're just pushing buttons. I know. And then number 3, what percent of the normal curve is greater than negative 2.15? So change your lower boundary. If you clear it all out and then you switch over, it will default back to the infinity, which is great. And so I'm going to go negative 2.15, I believe it is. Yep. So that's 98.4% of the area under the curve is that. And then draw that picture. This stuff doesn't seem too bad, does it? All right. Then they kind of throw us a little curveball. Is what percent of the normal curve is not between negative 0.08 and positive 0.08? Okay, so let me ask you this. What percent of the area is under the curve? 3-digit number. 100%. So if I change all my bounds on this,
isn't it just like the opposite of what the shaded percentage is?
Yeah, it is. It's exactly it. Oops. So if I do this, this is 100% of the area. So if I go negative infinity to positive infinity. So if I go negative 0.8 to positive 0.8, okay, the amount of area that is not between, so the amount of area that's in between is 57.6%. Okay, but they want what area is not colored. So basically, all you have to do is just do a little arithmetic on the next line decimals. Go, well, 100% is the whole area minus 57.6%. So that means that 42.4% of the area underneath this curve is not shaded. So gotta make sure you're paying attention on those kind of questions. Hey, we decided the quiz is Friday, right? And I won't be here Thursday, so I will have a video review that you can watch on your personal devices. Someone asked yesterday, well, do I have to be here then? Well, the sub will mark you absent. I mean, you're supposed to be here, but okay. I'm going to tell you this. Some of you will choose at some point to go to college. And if you have that very first day and the professor's going over how they're going to do scores, if they do this, you might want to run. Okay, you might want to drop the class. It might not be the one you want to be in. All right, so basically the college professor decides to use z-scores for every test. This curve is shown below. So if you have a score that's higher, 2 standard deviations or higher, you're going to bust out an A. If you have a score that's negative 0.5 to 2, you're going to get yourself a B. You have a negative 1.5 to negative 0.5, you're going to get a C. Negative 2.5 to negative 1.5, you get a D. And less than 2.5 standard deviations below. So they want to know how many A's, B's, C's, and D's are going to be available. Okay, well, they didn't give us the mean or the standard deviation, so we're just going to stick with the 0 and the 1. So clear these regions out. And again, they default back once you clear it and you move the cursor off of it. So I want bigger than 2. So 2 standard deviations above. My friends, this professor is a very mean, malicious professor. This is why I said you should run. You should go drop this class, or not this class, but the class that this professor's in. Because that means if I multiply 0.00 or 0.0227, that means that 2.3% are going to get an A. Yikes. I'm not liking this professor. I mean, the chances of you busting out an A in this guy's class, oh man, that's not good. And then the professor, maybe they'll save grace. Maybe you just want to have the B. Maybe this will be better. So negative 0.5 all the way up to 2.0. Oh, okay. Well, this might be a little bit better. When you take a look at that amount of area, this professor is basically saying that 66.9% will get a B. So I don't know, maybe you don't want to go high failing out of this class. Maybe they just make the A's harder to get. And maybe you might want to stick in there because that's a pretty good percent of people getting B's. And then the C's are going to be negative 1.5 all the way up to negative 0.5. All right, so our C range from negative 1.5 to negative 0.5, he's going to have 24.2%. Get a C. Okay, so he's pretty heavy centered on having the B in there, which is pretty good. And then your D range, this is for the student who like barely shows up, but like they're smart, but they barely show up. So negative 2.5 all the way up to negative 1.5. All right, this is looking a little better. This professor only thinks looks like 6.1% will get a D. And then, wow, if you are negative 2.5 standard deviations below the mean, there might be a sign that you might want to drop. All right, so negative 2.5. This is going to be a little area. Oh, okay. You know what? This professor, maybe I retract my statement because the probability that you're going to bust out an F comes out to 0.6%. So he's pretty happy about getting those B's out. You know, more than half the class is going to bust out a B, which is great. So I don't think, I mean, if you're the person that's worried about the GPA, this might worry me. But if you're kind of like, dude, I'm just getting through, happy about it. I know that there's kids that, you know, they've read every book in the library and they know everything. They can have that A. I'm happy with that B. I mean, I think that might be a pretty good spread of scores. Maybe I'll take my words back. Maybe don't run from this guy. But just realize if they do have this kind of grading scale, go and double check it. I mean, this basically means that they're going to if they're going to renormalize their class every time, and if you have a whole bunch of people like you're like, dude, I knew that dude in high school, and like, you know, they weren't smart, you might want to stay in that class. If you're smarter than the other people that you see in that class, you might want to stick in there because chances are you're going to create the B if he has a better distribution each year, which is possible. All right, let's clear that out. And then Number 6, explain the consequence of using normal CDS calculated percent of each letter grade. In fact, these grades are not normally distributed, but maybe skewed left. So if it's a skew left, that means that the mean is to the left of the median. It's pulling it to the left. So that might not have the best impact. If you don't have a normal distribution, you should not use the normal distribution. Okay, if you have skew left or right, we talked about that quite a bit. We don't really have very skew on this one because that's normal distribution. But if it's skew left, that might impact grades in a bad way. If it's skew right, it might actually come to your advantage. I don't know. But if it's skew right, that actually means that you might have gotten like a 93% in the class and you still got the B. And you're like, wait a minute. And explain why a z-score of positive 3 is more unlikely than a z-score of positive 1. Okay, well, we can just keep doing our normal distribution. So, a z-score of 3. If I did a z-score of 3, you're talking about 99.8% of, or not actually 99.9% versus z-score of 1. If you just change those, z-score of 1 takes over 84% or less than that. Okay? And it says z-scores theoretically have no upper or lower bound, therefore observations are off the bell curve are unlikely but not impossible. 8 standard deviations above the mean should be very rare. What percent of the normal curve is greater than 8%? Or a positive 8. So if I change that, if I put an 8 in here, oh my gosh. You guys know how to read scientific notation? All right. So 6.22 times 10 to the negative 16.
That's a really small number.
So the chance of you being 8 standard deviations or beyond to the right is, okay, hang on, I got to count. Ready? Decimal. With me? Decimal. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 6. So this type of thing, you have a better chance of getting struck by lightning, winning the lottery, and surviving both. Not like winning the lottery and having a heart attack the next day, right? All right. Hey, that's how we run through these things. Is that okay? So I'm going to go flip back to 3-5. In the notes, I don't know what page this is. You guys know what page it is? You're smart. I'm sure it's not. 76. Thank you. All right. So this says the standard normal distribution is the distribution of z-scores always with a mean of 0 and a standard deviation of 1. So they say you have a normal distribution, but they don't give you the mean or standard deviation. Just use 0 for the mean, 1 for the standard deviation, and it's going to work fine. But then it says IQs are normally distributed. So watch this. I'm going to get rid of that. So this is our normal distribution. But if I wanted to say, hey, let's do the IQs. If we do 100, 15, it's going to give us normal distribution. You just have to make sure you hit the plus. So there's your normal distribution of IQ scores. Okay? If it says lengths of typical pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. Okay, again, you just plug in the means, the first number, so 268, 15. And it doesn't really show up yet, so you hit the plus. There's your distribution of pregnancies. Okay? Heights of U.S. males are normally distributed with a mean of 69 and a standard deviation of 2.5. So just know when you're doing this, you're not dealing with the z-scores. You're actually dealing with the stuff. So 69, 2.5. So there's your distribution on the heights. Many other variables are normally distributed or close enough to normal that the bell curve makes an effective model. Okay, your calculator, aka Desmos, can handle this very nicely. So when you are doing this on Desmos, almost everything you possibly could need is right here. Normal distribution, first number is the mean, comma, second number standard deviation. And then you just have to say, am I going in between two numbers? Am I going below a certain number, or am I going above a certain number? Okay, so those can definitely work. So let's move the paper down. So again, the stuff down here where it says normal CDF, LV, UV, mu, and phi, that's if you're using the TI graphic calculator, which is fine if you want to walk you through it. I just like Desmos because I'm kind of think it's fun. All right, so let's take a look at the IQs. Overall mean is 100, standard deviation is 15. What if someone obtains an IQ of 109? What percentile IQ is that? Okay, so if you were to look on here and you plug in the 100, 15, it's going to work nicely for you. So I have a mean of 100, standard deviation of 15. If I do this, and of course it's already doing, and then what would say, what if someone were to obtain an IQ of 109? Okay, so I'm going to delete this, negative infinity, type in 109. So basically, the chances of you randomly selecting a person out of the population and they have an IQ of 109 is roughly a 72.6% chance. Okay, that's how you kind of look at it. And the weird thing is how do I make a random selection from a population? Again, there's different ways that you can give numerical values to people, use a random number generator to come up with it, but there's lots of other ways. All right. All right, we can calculate the percentage normal distribution shaded by using the calculator. Okay, again, the normal CDF is on the calculator. We're not going to do that. We're just going to continue to use Desmos as normal distribution. It works just fine. The resulting percentage in this case was 72.6%. We agree with that. Therefore, approximately 72.6% of the population is below an IQ of 109. So a few more examples are provided below without normal distribution. So what percentage of IQs are between 88 and 117? So I have a lower bound of 88, upper bound of 117, so I'm not using the infinities. Just plug those straight into Desmos. It works nicely for you. You guys shouldn't be getting all sick before Thanksgiving like this. You need to be healthy for the Thanksgiving Day football game. You know, the one where the adults my age go out and then have to see an orthopedic surgeon because they blow a knee out. That's why I don't play the Thanksgiving. You get the one guy who's a little too intense. All right, so what percent of people are between 88 and 117? So if you look at Desmos, we have 0.6596, which is about 66% of the area is in between that. What percent are greater than 96? So change this one, just delete it, goes back to that, are greater than 96. So you have 60.5% are greater than a 96 IQ. What percent are less than 66? So you change your lower, clear it, goes back to infinity, are lower than 66. 66 your top one. So you're talking about 1.2% of the population has an IQ that is lower than 1.2%. So sometimes proportion is requested, it's not present. A proportion is considered a decimal equivalent to the percent. For example, 45% is equivalent to 0.45. 0.45 is the proportion. The proportion is the decimal form of the percentage in statistics. So, and then, I mean, we say round 3 decimal places. Honestly, if you gave me like 22.5, you're totally fine. Okay, I'm not worried about going like 3 decimal places out. So one thing that I want to talk about, let's get rid of this. All right. My football players, this is directed to you because we have a game come Friday against Erie. Is that right? All right, football players, I'm going to ask you some stats. Who's our best running back? Jay Fox. And is he doing okay? Okay. It's not a break? No? Okay. So give me a ballpark figure. What do you think he averages on a run each play that he would play? If he's given the ball, how much do you think? How many yards? About 6.4 yards per. Okay. All right. I don't know. Okay. We'll go with the 6.4. Now, we're just going to make up a standard deviation because I don't have all his data, so I can't do it. So let's say his standard deviation is 1.6, meaning that 68% of his runs are going to go between 6.4 plus or minus 1.6. All right. It's the big game. It's Friday night. You with me? Okay. It's 4th down, but we're on the 7. Okay. Now, I'm not telling coach how to coach. I'm not being that guy at all. But as a statistician, if I thought I knew Jaden Fox? Yeah. If I knew Jaden Fox's stats, and we're talking university level, big university schools and or NFL. Nerds like Stirrup are going to make the call to the guy who's sitting in front of me in the press box for that guy to make the call down to coach, for coach then to give the symbol of what play to run on the field. Literally. Like now, it doesn't happen here at Creek, not yet. Yeah. I'm working on getting myself in the press booth. Yeah. And then so 4th down, final few seconds. Creek is down by 4. They got to get the 6. Point after is not going to matter, but this is going for the win. All right. So we're calling down. It's like, call this play. Call play ABC for Fox to carry. Like, yeah, but it's 7 yards. But the probability he is going to go 7 or more yards is 35.4%. If that was true. If the 6.4 was accurate, obviously we made up the 1.6 we didn't know. But basically, that is your sports statistics of anything. Now, true story. Let's see. This is quite a few years ago. Bry Rudd. Remember him? Quarterback? He lost starting quarterback position, and then they put him in the game, in the state championship. Last play of the first throws that 65-yard pass to Ish. We don't score, but it's kind of like, oh, these guys haven't seen that kind of air coming out of a quarterback, which might have been a pretty good strategy for us. So I told Bry Rudd, I told him, I said, give me your stats. I don't remember what exactly his stats were, but basically, let's say his completion on passing was 17 or more yards. And he actually gave me all his data, so I found out his standard deviation. I can't remember, but let's say the standard deviation was 4.3. So after the game, so he went in and he just starts putting air under that ball like crazy. So he's like, okay, what's the chance he throws a completion for 18 or more yards if that was his data? And that's a 40% chance. What's the chance that he throws for 15 or more yards? 67, almost a 68%. What's the chance that he throws 5 or more yards? 99.7%. Each play. I mean, that's sports statistics right there. And the funniest thing I see Brian after the game, after he goes through all the pomp and circumstance and all the interviews and all the good stuff and the handshakes and the hugs. He comes running up to me and goes, Stirrup, you told me what my average was. You told me the standard deviation. And I'm sitting there and I'm thinking about it during the game. I'm like, you should never do that during the game. But it worked. And obviously we beat Columbine, even though our mascot got his butt kicked and they stole the head and they were throwing around the Columbines. Or no, it wasn't Columbine, it was Valor side. Yeah. So, yeah, that was fun. But I kid you not, these are real types of, like, if you have any interest in all in doing sports statistics, think about this. Like, me as a teacher, don't you think I think it would be pretty cool if I was in the press box or the coach's box and I'm crunching data, but I'm able to watch the game and I'm like, put this, hey, coach in front of me. Yeah, idiot math teacher behind me. Hey, if you play this play with this person doing this run, we have a 99% chance that this is going to take place. Okay, call down, boom, call's played. All of a sudden, if that does happen, really good. And they're like, dude, this mathematician, geeky math guy, he's pretty cool. If it doesn't work, it's like, dude, get out of here. So I'm just telling you how sports statistics works, and that's a very pivotal way to do it. And they usually NFL teams that have a lot more people like me who are back there just crunching numbers. And they might crunch the numbers before the game, and then the other coaches are kind of reading the statistics going, I call the math guy. I don't know what this means. So, but that's the ins and outs of, normal distribution, which I think is pretty cool. So what we're going to do tomorrow is we're going to keep this normal distribution, and then we're going to add a little bit to the back end of it. Because what's going to happen is I'm going to say, hey, we have this percent of area. What is this number down here, and how do we find it? And it's just a matter of adding. You add a period, and you put normal CDF behind it, I think is what we use. Or inverse CDF. I can't remember. I'll figure it out by tomorrow, hopefully. All right. So you have some perspectives on me, on math. So, my friends, would you give 3-5 a try? And what my plan is for Thursday, like tomorrow I'll go over this, I'll teach 3-6. So then I will go over 3-6 in my video, and then I'll go over the review, which is the following page in the video, and then y'all be really good and prepared for the quiz on Friday. The quiz on Friday, friends, there's no multiple choice. Sorry. But if you could use Desmos, you could do the whole test. Yeah.
I have a question about
Yeah. Oh, let me hit stop real quick.